Hi, and thanks for joining the AWS CloudFront Fundamentals session. We'll go through the features and benefits of using CloudFront, as well as a few of the recent things we've disclosed over the last 12 months. My name is Tsuri Tamaim. I'm a Solutions Architect Specialist for Edge Services. And what I hope to give you over the next 30 minutes or so is a broad overview of what you can accomplish by using CloudFront technologies, alongside some of the recent features that we'll mention. So just as a quick refresher, CloudFront is our CDN service, our content distribution network service. It's built out of edge locations spread out globally, really close to where your users might be. These edge locations will then receive requests coming from your users, transport them through a secondary tier level, which we call regional edge caches, all the way back to the origin, cache the responses, and then deliver the content to the users from an edge location as close as we can provide to them. Typically, when users are using CloudFront, they are using it for both dynamic and static content, either for caching, acceleration, security, performance, and availability of their application. Currently, we have a little over 220 edge locations spread out globally. Over the last 24 months, we doubled the number of edge locations, together with 12 regional edge caches. Most recently, we've added a new regional edge cache in Ireland, providing us with one extra regional edge cache in Europe. And if you look at the spectrum of CloudFront users, you'll typically see a very broad spectrum of who's using CloudFront. You'll see media and entertainment customers using it for caching, acceleration. You'll see gaming customers. You'll see financial services where latency is really key. But you'll see e-commerce. You'll see enterprises. You'll see ad networks. Pretty much anyone who has a public-facing application where latency, security, performance is key is a good candidate to start using CloudFront. When we look at CloudFront, we look at three basic tenets where we want to deliver value to our customers. The first of which, well, obviously, security is always a top priority for us. So security will be key in the features that we're going to cover today. Another key element is providing availability, better availability of your application, and performance. Obviously, when we talk about performance with CloudFront, we talk about two different aspects of performance. One is providing a better user experience, providing content as close as we can to your users, providing faster responses from cache, or just dynamically accelerating the content from your user to the origin. But another aspect of performance is reducing the load on the origin, right? So the better the cache hit ratio, the more we can handle at the edge from the security perspective, from the business logic perspective. The more we can handle at the edge, the lesser the load on the origin would be, removing overhead, reducing the footprint, obviously, minimizing your costs at the origin. So let's start with what we said was the basic tenet for us, right? Security. So when we talk about security with CloudFront, we typically speak about three different elements of security that customers are benefiting from when they use it. One would be access management and access control. So it could be access to the distribution, access to your content, access to your origin, controlling access to the origin. All these aspects can be easily achieved by utilizing CloudFront capabilities. Another aspect of security would be transit security. So using encrypted connections, using proxy architectures to protect your origin, protecting data in transit. That goes into CloudFront as well as our added services that you can attach to CloudFront, services such as AWS WAF, which is our layer 7 protection service, protecting your application from malicious content streaming from the internet, as well as Shield. Shield is our DDoS protection service. It is already enabled by default on CloudFront, and we'll speak about that a bit later. We have ACM to provide you with seamless, free of charge TLS certificates for your distributions. So there's definitely never a good reason not to encrypt data in transit by using TLS. As well as, the typical security services such as IAM for access management and control, as well as CloudTrail and Config for auditing purposes. When we talk about security, typically we mention shared responsibility model, right? Some aspects of security are AWS's responsibility, while other aspects are the customer's responsibility, and the same goes for CloudFront as well. So Out of the box, when you start using CloudFront, there are a few benefits that you stand to gain simply by turning it on. One good example would be Shield. So Shield standard is a default setting. You just get DDoS protection out of the box whenever you start using CloudFront. There are other services such as ALB that benefit from Shield standard out of the box. And a recent addition we added was the ability to see whether or not you're actually being targeted by a DDoS attack. So before, we had the DDoS visibility dashboard only available to paying Shield Advanced customers, but a few weeks ago, we announced the addition of visibility dashboards for all CloudFront users. So now you can easily see whether or not you're being targeted, and maybe if you are being targeted, you might want to consider adding some added security features, such as WAF. Another thing we baked in was protection against an attack that became common over the last year, the HTTP desync attack. So we incorporated a new protection through HTTP Guardian, already baked into CloudFront. So basically, whenever you enable CloudFront, you're already protected against these desync attacks that typically target proxy mechanisms over the internet. A few other features you stand to get out of the box would be OCSP stapling, that basically makes sure that the user, when they receive the certificate that we present when they access the distribution, is valid and it hasn't been revoked. And we staple that assurance to the request, to the response we deliver to the viewer, as well as domain fronting. Basically, we make sure that the TLS certificate and the domain that is registered and is being requested through the request belong to the same business entity, providing you protection against such fronting attacks. We do the same by making sure that no one can register your distribution CNAME in a different account. So if it's your CNAME, no one else can publish it through CloudFront. Another addition we've made around security is the support for TLS 1.3. So TLS 1.3 is the most recent version of TLS for transport layer security. And with TLS 1.3, there are a few benefits that come to CloudFront. One of them is the deprecation of old, weaker ciphers. Another thing that is enabled by default for TLS 1.3 is perfect forward secrecy. And another nice thing to know that whenever we started supporting TLS 1.3, you started using it as well. So automatically, it's enabled by default. It's even enabled for existing distributions. Support for this new version. One day, your users just started receiving handshakes on a TLS 1.3 version. That was an immediate effect. Another effect of TLS 1.3 is around performance. So performance, basically the TLS handshake takes one round trip time, where before with TLS 1.2 or before it took 2 round trip times. That's really drastically removing a lot of the latency in creating the initial connection to CloudFront from the viewer. One other thing to note is the way we handle our TLS libraries is not through the well-known open source library of OpenSSL. We're using our own library called Signal to Noise, S2N. It's an open source library. You can use it on your own if you want to. The benefit of using it is, one, we control it. We know what goes in it, and it's a very small library. It's only around 6,000 lines long, where with OpenSSL is over 500,000 lines. So it allows us much better control over what goes into that piece of code. It's also mathematically proven to be non-vulnerable to TLS attacks. So if you want to know more about it, read more about it, make sure to check out the link down below on the slide. Moving on to the content protection aspects of using CloudFront. So there are 2 key features that you should definitely know about if you want to make sure that your content is being protected. One of them is signed URLs and signed cookies. This feature allows you to make sure that whoever tries to access your content is doing so in an authenticated manner. This is especially useful if you have media files that you have protected behind a paywall. So you can easily enable that. And a recent addition was also the ability to use non-root users to sign these URLs and cookies. Better sticking to best practices. But it allows you to provide that kind of logic, enforcing that authentication at the edge, instead of going all the way to the back end, beating the purpose of CDN So now CloudFront can do that for you, validate that the user has access through the signature it provides, providing them the content that they need. Another feature around content security is called field level encryption. This specific feature comes in when you want to make sure that no one can access specific parts of the HTTP request, such as maybe a credit card number or a password field. So you can use that to have CloudFront encrypt that specific piece within the content, within the HTTP request, all the way back to the backend, to your application. And even then, only parts of the application that has access to the private key can decrypt that component of the request and use it, right? So even though you might use a secure transport layer, right? You might use an encrypted channel to get the traffic all the way from your edge location to the origin, you still need the private key to decrypt that piece of the request, making sure you stick to security best practices, keep your user privacy and security. The thing with security is, well, we have all these cool features that you can definitely use and take advantage of, but a lot of security is typically customized. So you do want to provide your application with some security features that are only specific to your line of business and your application logic. And this is where Lambda at the Edge, our compute engine at the Edge, comes in. There's a ton of things you can do with it, not only around security. You can improve performance, you can normalize URLs, you can use this for header enrichment, or any number of things, and there's a good sample page down on the link below that you should definitely check out. But specifically speaking about security, there are a few things you can do with it, like token validation, like request signing, and one of my personal favorites is adding security headers to the server response, increasing the client-side security. Headers such as HSTS and CSP. These headers are being enforced at the client side. Super easy to deploy on CloudFront, as I'm going to show you on this quick demo. So basically what we have here is a Lambda function. It's written in Node. It's a simple copy and paste from the samples page I've shown you before. And what it does, it adds these 6 headers to the server response. So I basically just copied and pasted this function into my Lambda at the Edge console. I click deploy, I choose my distribution, I choose to attach it to the origin response, which means that the response with the headers will be cached and served with the security headers on all subsequent requests. So I only need to run this function once, and that's it. I've deployed it, and this effectively brings my website from an F score to an A+ score on the Mozilla testing site. Not only that I got a nice score, which is always nice to have, right? But it also provides actual security to your users, right? Their browsers will now start enforcing all of these security headers that we've added into the response. So basically speaking about security, there is a lot to gain. We mentioned adding services like Shield and WAF, using out-of-the-box features, using TLS 1.3 out of the box, using Lambda for customized security features and settings you can deploy at the edge. All these make great sense if you're starting using CloudFront. Moving on to availability. So, right, another aspect of using CloudFront is providing as high of an availability for your application as we can. And with availability, there are a few recent additions we've made to make it easier for you to control how you treat your origins. So one thing we've done is added a customizable timeout that you can use to control how aggressive you want to be with how long you want to wait for a server response from the origin. So if you expect very good latency, very good response times from your origin, you don't have to wait that long. So we default to 3 attempts or 10 seconds. That means that we will wait for 30 seconds before we know something went wrong. You can now configure that and make it as short or as long as you feel comfortable with to control the availability of your website. But what happens if your origin goes away completely? Let's say someone deletes your bucket or removes access to it, if it's a bucket that acts as an origin, or something went wrong with the application. So for that, we have something that is called origin failover. And with that, you can configure a secondary origin, right? And you can group these 2 origins together on a failover group. And these 2 origins will act as a single group where we fail over to the secondary once we start seeing issues with the original origin. This is done under the hood for you. There are no TLS renegotiations from the client side, no routing changes, no DNS propagation changes. This is done behind the scenes. CloudFront will start sending traffic to the secondary origin for you. There's a really cool blog you should definitely check out that takes this to the next level by the use of Lambda at the edge, really providing you with high customization around how you want to perform origin failovers. Make sure to check out the link below. Another aspect of availability is visibility. We've always had access logs coming from CloudFront where we can have logs sent over to S3 where you can diagnose them and look into them, and perform some analytics, maybe BI. But we heard from customers that they want to be able to act in real time when something changes, right? They want to know in real time when there's an increase in error rates at the application level or if there's a change in behavior from the user side. So we've added a functionality that is called real-time logging, where you can easily control what fields go into a log. You can easily control the sample rate, but the most important thing, you can have the logs appear on Kinesis data streams within a few seconds of the request being received consistently, right? So by adding this new feature, we now allow you to dissect and inspect your logs in real time, whether it's through a worker that works directly on the Kinesis data stream or through an Elastic dashboard that you can query. Through any kind of querying language, you can use Athena to query your S3 bucket where the logs finally land, or you use any kind of custom dashboard or functionality to investigate through these logs. I'm going to show you over a really short demo how this looks like. So basically, I'm just navigating to this new log menu on the CloudFront console, clicking the real-time log configuration tab, and I'll create a new log configuration. I'll just give it a name. Let's say I'm going to keep it at 33% sample rate. So I'm going to punch in 33. I'm going to pick which fields out of the 40 fields available go into that log. I can keep all of them if I want to. I can keep it really slim or really verbose, depending on what I need to be inspecting. I will pick my Kinesis data stream to be sending it to. I'll pick my distribution. I'll pick the behavior because we can enable this on a behavior level. This is pretty much it. Once we enable that, all requests coming into CloudFront, that specific distribution with this specific behavior will start streaming straight into Kinesis, where I can start acting on it. This is specifically important for clickstream tracking, ad networks that you really need to be able to react when something changes in the application. So just summarizing a bit around availability. Make sure that you monitor your application. Use CloudWatch error rates to trigger events. A nice feature you can use is trigger a change in the sample rate once you see an increase in error rates from CloudWatch. So we have CloudWatch automate a change to your configuration, your logging configuration, to drive sampling from, let's say, 1% to 100%, so you can have verbose logging. Use custom error pages, right? If you ever had a chance to encounter the Amazon.com website where you see like a nice looking dog saying, oh, something went wrong. This is utilizing like a nice error page instead of like having an ugly 503 response page coming from the application. And you can keep those as very short time to live because you don't want to cache error pages for very long. If the application just had a hiccup, you want to be able to serve content as soon as you can. And use origin failovers, right? Make sure that your origin is always available. And if you have two instances, maybe it's an application in another region, make sure CloudFront is aware of it so they can route traffic to your other instance. Moving on to the last area that I want to focus on today, which is performance. And with performance, very much like with security, it's a shared responsibility thing, right? There are some things that AWS does for you under the hood to improve application performance, both on the client side and on the server side. But there are some things you should definitely be aware of and do on your own if you want to drive the most out of CloudFront in regarding performance. So the first thing you should do is definitely check out the blog that I have a link for down below. It goes in real depth about how to best use CloudFront to have your application perform as best as it could. So make sure to check that out. But a few things to consider are you always need to make sure that you have the proper caching strategy, right? So make sure you know how your application is structured, which parts of it should be cached, which shouldn't be cached, for how long. And once you do that, really drive that cache hit ratio up. By hitting cache hit ratios up, you do two things. One, you reduce the load from the origin because more content can be served from cache, but you also improve the customer experience. Obviously, they're getting their content from a very nearby edge location instead of traversing the world to get a file out of your server or origin. So keep that in mind, but also keep in mind that you should definitely take use of as many features as you can at the edge. Simple things like redirection, right? You don't have to traverse the entire world just to receive a 302 redirect command from the origin. Make sure you do that at the CloudFront level. Save time. Use features such as compression, right, to save bandwidth. Use origin shield that I'll talk about in a minute to reduce the load on your origins. These are the things you should definitely think about when you configure CloudFront. Don't use it just as is out of the box. But if you still use it just as is out of the box, there are a few things that we've done to improve performance on your behalf. Things like TCP optimization. So whenever a user starts their TCP handshake with CloudFront, we will use TCP fast open, which means it only takes one round trip to establish a TCP connection. So that's one round trip for TCP and then one round trip for TLS 1.3. That's only 2 round trips before users can start pushing the requests toward your origin through CloudFront. That's a massive improvement in performance. Some other optimizations around TCP, like BBR and congestion control, routing. These are things we're doing constantly to improve latency. And keep in mind that whenever you hit CloudFront, traffic from CloudFront to your origin, if your origin is on AWS, this traffic traverses our very own backbone. It traverses our dedicated network. It does not traverse the internet. So you are expected to gain latency improvements even if you're never using caching at all, if it's all dynamic. Another thing we added was dynamic content placement that I'll describe in a couple of slides that does things for you in order to improve your cache hit ratios. So the one thing we've done to make it easier for users to start using CloudFront effectively around caching is the decoupling between what goes into the cache key and what is being forwarded to the origin. Before we had, and you still can use it in legacy mode, where you control what elements of the request are relevant for the cache key and which aren't. By that, you basically eliminate them from the request entirely. But now we decoupled that, and with cache policies, you now can have a finer level of control over what goes into the cache key. And obviously, you can still control the TTLs and such, but you have a finer control whether or not you want to have specific cookies going to the cache key, and then you can have separate objects saved under a different cache key based on, let's say, the session cookie, if this item should only be kept in cache for that specific session and no others. But you can also say that user agents don't go into the cache key, right? So you can have a fine control over what goes into the cache key and what doesn't, without any correlation to what you want to send over to the origin, and we'll see that in a minute. Another thing we've added is the support for broadly compression. So we've had gzip compression. Basically, by enabling compression at the edge, you tell CloudFront, please save money, right? You're reducing the payload size, you're sending out less traffic, your data transfer out costs will go down. And with broadly, we've seen a roughly 24% improvement over gzip. So enabling this simple checkbox at the bottom of the caching profile will basically save you 24% of what you've saved already through gzip. You can now do with broadly. So we mentioned that you can control separately what goes into the origin, and you do that through the origin policy page. And with that, you can do basically the same that you do with the caching profile. You can control which headers, which cookies, which query string parameters go into the request as it goes through the origin. But we've also added capability around finer grain geolocation, like longitude and latitude, that you can send all the way back to the back end to your application to do some analysis, maybe security, maybe customized content per country, per city. All these added geolocation features are now there for your use. But we also have other headers you can add through the origin request policy, such as whether or not the user is a mobile phone, whether they're using iOS or Android. All that can be sent over to the origin and have some decision-making processes done over there. Moving on to a very recent announcement we've made was that was Origin Shield. Origin Shield is one of these features that can dramatically improve your cache hit ratios if you have content that keeps on getting updated, such as game updates or live media. All these use cases can really benefit from Origin Shield. And I did mention that we have two tiers of cache, right? We have the regional edge caches, that they're the one that request the data from the origin in case the edge cache doesn't have it in cache. So a user will go into the edge cache. If the object is not there, the edge cache will request the object from the regional edge cache. And if the object is not there, it will go all the way to the origin. So imagine a scenario where we just release an update for a massive game, right, with millions of users. These millions of users will be hitting a lot of edge locations, and these edge locations won't have the file because it's brand new. So that these edge locations will hit the regional edge cache, they won't have the file as well, and all of the 12 regional edge caches will be hitting our origin. This could be dramatic, right? This could have a dramatic effect. The same goes for live content, right? It's getting delivered as the live content is being produced. So for these use cases, we released Origin Shield, which allows our users to designate one of the 12 regional edge caches as the Origin Shield, which forces all regional edge caches to check with that specific regional edge cache before traffic is being forwarded to the origin. So basically, let's say you have this new game update or a live media event, the origin keeps on producing new chunks, the edge caches don't have it, they will ask the regional edge caches, they won't have it. Instead of going to the origin, which might overwhelm the origin, they will all go to the regional edge cache, so to the origin shield, which will store the object once and then send it out to all subsequent requests without bothering your actual origin. This could dramatically remove a lot of the load on the origin, specifically in very dynamic content type of environments, live media, gaming, and such. So that's one of the things you can enable on your own. Another thing that we've added that allows you a better cache hit ratio is something that you have no control over, which is called dynamic content placement. And by that, we introduced a new concept of a city, and it's only applicable to these large, very large areas where we have multiple edge locations concentrated around the same city, such as LA or SFO, London, any one of these places that have multiple edge locations. And it does help to solve a scenario when I go and fetch a file, right, a new file, let's say it's a game or media file or whatever it is. Very popular object, so I would be hitting one of these edge locations around my city randomly, and then if my neighbor asks for the same file, well, they can randomly hit another edge location. This will bring down cache hit ratios, right? So with dynamic content placement, we're able to control which edge location we pick for each distribution, and we use a bidding algorithm to make sure we don't overload any of the edge locations. So basically what now happens, I will ask for the file, for the new file, it will be fetched from the origin, stored at the edge location, and then if my neighbor asks for the same file, they will be hitting the same edge location. Again, providing them the content with a very nearby edge location, removing the load from the regional edge cache, from your origin, subsequently driving up customer experience. If you want to hear more about performance improvements, we have a session specifically around that, so make sure to check out Net 404 session. It really goes deeply into improving performance and availability around CloudFront, so make sure you hit that. Other than that, I'll thank you for joining. Hope you enjoyed the content, and I'll appreciate if you can leave your feedback.